Hello everyone, welcome to the electrical circuit analysis class. Today our topic is on three-phase circuits. Okay. So the learning objectives of the today lecture is to introduce the polyphase system. So poly means more than two. More than two is also called as polyphase. So single phase, one phase, two phase, three phase, four phase, five phase, any number of phase. That is called polyphase system. And next one is to list the advantages of three-phase system. The third learning objective is to understand the balanced and unbalanced systems. And the fourth one is to understand the connections of three-phase system. Okay, so let us see one by one. So coming to the three-phase. So generation of three-phase voltages in a three-phase alternator or three-phase generator. Consisting of, this is three-phase generator, so consisting of three windings, let us say A, B, C. So this coil has A1, A2 is a one phase, and B1, B2 is another phase, and C1, C2 is third phase. So in this three-phase generator, so three voltages are generated simultaneously with a phase displacement of 120 degrees apart. Okay, therefore here the voltage, phase A voltage VA is equal to Vm sin omega t. So if you take the A phase voltage is the reference, so these can be represented in the polar form. VA is equal to V phase at an angle 0 degrees. Then the B phase voltage VB equal to Vm sin omega t minus 120. Minus 120. That means here this B phase voltage is displaced, phase displaced by 120 degrees apart from the A phase. And coming to the C phase, so VC is Vm sin omega t minus 240 with respect to the reference, that is A phase voltage. And VB to VC is 120 degrees. Okay, that means each and between the two phases, the voltage difference is, phase angle difference is 120 degrees apart. Therefore, Vp is equal to V phase at an angle minus 120 degrees and Vc equal to V phase at an angle minus 240 degrees. So this is the three phase waveforms. So how the voltages are simultaneously generated and what is the phase displacement. This waveform is showing the phase displacement between the any two phases, phase voltage is 120 degrees apart. So this, if you say that A phase, B phase, C phase, you can also say that R phase, Y phase and B phase. So red, yellow and blue and yellow, something with any three colors. So coming to the polyphase system, so polyphase alternators have two or more windings here symmetrically spaced around the armature. So such alternators produces many independent alternating voltages. That means if you select the one phase, so single phase voltage. If you select the three phases, so three voltages. So six phases, six windings, six phases means six voltages, like that. And these voltages in the individual windings have the same magnitude and phase displacement is 120 degrees. Of course, the magnitude and frequency is same, but only the phase displacement is 120 degrees apart. So this phase difference depends upon the number of windings. See, total angle is how much? 360 degrees. So we are taking the three-phase system, therefore 360 by 3, that is 120 degrees apart. Now if you take the six-phase system, so the phase angle between the each and every phase is, between the any two phases is what? So 360 by 6, that is 60 degrees apart. So like this you have to calculate. Now, what are the advantages of this three-phase system? What are the advantages of this three-phase system? Especially in polyphase system, we use mostly three-phase system because three-phase system has the more advantages compared to any n-phase system. Okay, but here we will talk about what are the advantages of three-phase system over single-phase system. First, the output of a three-phase machine is greater than the single-phase machine of the same size. Now, you take one machine which has the same size, single-phase machine one side and three-phase machine another side. So, the output of the three-phase machine is more compared to the output of the single-phase system. That means, let us say 100 volt amperes of the output of the single-phase system and three-phase system 300 volt amperes are output. 300 volt amperes is the output of the three-phase machine. and the total power output of a three-phase machine is not fluctuating in the case of a single-phase machine. So it has a higher efficiency. That means, see, we have seen just now here waveforms. See, this is not fluctuating. It is a continuous signal, continuous generation. But coming to the single-phase system, there is a fluctuation in the voltage levels. Okay, and a three-phase transmission needs less conducting material than a single-phase transmission. Hence, transmission becomes economical. That means, if you transfer the 100 volt amperes power using single-phase system, okay, you require more number of conductors. For the same, to transfer the same amount of power, 100 volt amperes, the conducting material, that is conductor requirement, is very less. We can neglect that means we can save the copper cost. We can save the copper or conducting materials, or conductors. Okay. Now, three-phase motors are self-starting, whereas single-phase motors are not self-starting. Again, you have to use the starting methods to start the motors. And power factor of a single-phase motor is always lower than that of the three-phase induction motors. That is, three-phase motors of the same output and for the same speed. So, these are the various advantages of the three-phase system compared to the single-phase system. We can save the cost, okay? You can save the copper, that means some amount of power can be saved. It is economically it is beneficial compared to the single-phase system. Okay? So, these are the few advantages of the three-phase system over a single-phase system. Next, coming to the some important definitions of this three-phase system. First one is symmetrical system. So, what is symmetrical system? Means a three-phase system in which three voltages are of same magnitude and frequency and displaced 120 degrees phase angle from each other. It is called as a symmetrical system. That means the magnitude is same and the frequency is same. And in the three-phase system, the three voltage and three current values are three quantities are displaced by 120 degrees apart. Then the system is called symmetrical system. If any one is violating this, either magnitude is not same, or frequency not same, or phase displacement is not equal to 120 degrees between any two phases, or three are not equal, then the system is called unsymmetrical system. Okay. Now, what is the phase sequence here? So, the sequence in which the voltage in a three-phase reach their maximum positive value is called phase sequence. That means, now we have seen here these voltage waveforms here. See, first VA is reaching the maximum. I am comparing it to 0. Let us say 0. Okay, starting at 0, the waveform A waveform is started and it is reached the maximum value VA at some angle. Maximum value is for A phase is VA, and after the VA, VB. After the VB, VC. That means phase sequence is ABC like this. Phase sequence is ABC. So that's what here phase sequence. A sequence in which the voltage in three-phase system reach their maximum positive values we are calling as a phase sequence. Now, next, what is my balanced system? A three-phase system is said to be balanced. Okay, if all the phase impedances are identical, that means all the phase magnitudes are identical, magnitudes are equal, and phase angle of all the impedances are identical. Phase angle must be 120 degrees apart, and all phase have same power factor. So then the system is called balanced system. So let us see the example of this figure. Now first see the first A figure. So VA, VB, VC. VA vector length of the vector and VB and VC vector length is equal. This same means the magnitude is same. And the phase displacement is 120 degrees, 120 degrees, 120 degrees. That is VA to VB 120, VB to VC 120, VC to VB, VC 120 degrees. Then this figure here represents it's a balanced system. Now observe the phase that is figure B. So in this figure B, the magnitude is same. See, VA, VB, VC, magnitude is same, but phase displacement is not satisfying the 120 degrees because VA to VB is greater than 120 degrees phase displacement, and VB to VC and VC to VA, it is less than 120 degrees phase displacement. Therefore, this B figure represents the, it's a unbalanced system, unbalanced supply, unbalanced system. Now figure C represents see the figure C. So figure C represents here, magnitude is different here. VA and VB are equal in magnitude, but VC is not equal in magnitude with respect to VA and VB. Of course, phase displacement is 120 degrees apart from each other. Therefore, this C figure also indicates it's a unbalanced system. And now see the last one, that figure D. So which represents what? Here, phase displacement is not 120 degrees between any two phases, and also the magnitude also not equal. Then this also comes under the unbalanced system. Okay, so balanced and unbalanced, this is the difference. So if the three impedances, see that is a balanced supply here. Okay, balanced supply. Now what is the balanced loads? If the three impedances which may be star connected or delta connected are equal, then the three phase load is said to be balanced load. Okay, if a load and supply are both balanced load, then the three phase supply system is balanced system. Load is balanced, supply is balanced, then it is a balanced system. If the load is anyone is unbalanced, then the entire system becomes under the unbalanced system. So under normal operating conditions, under normal working conditions, a three phase system can be taken to be balanced. Okay, normal operating condition, everything is fine means it's a balanced system. Okay. Now, what are the different connections here involving in a three phase system? See, in a three phase generator, the connections are how we are giving the connections. Depending upon the connections, we have the mainly two types of systems here: star connection system and delta connection system. Okay, star connection, which is also called as Y connection, and the second one is delta connection, which is also called as the mesh connection. Now, if you by seeing this figure, you can easily observe that. First, see the star connection. So, in this star connection, like terminals of the coil, either starting terminals or ending terminals. So any coil has two terminals, one is called starting terminal, another is called ending terminal. So if you connect all the like terminals at a point, then it will lead to the star connection. Or if you connect all the ending terminals at a point, then it will lead to the delta connection. Okay, so where we are connecting this all at a point, so which leads to the one more point called neutral point. Okay, the point N, which is known as the neutral point or star point. Next, this kind of connection is also known as four-wire three-phase system, because here we have the three phase here, phase R phase, Y phase and B phase. Because we are joining all the like phases, that is like terminals, that is the ending terminals or starting terminals at a point, so which leads to the one more connection, that is one more point called N, that is a neutral point. Therefore, this system we are calling as a three-phase four-wire system. Three-phase four-wire system. Now, next one is a delta connection. So, in this connection, finishing terminals of one coil is connected to the starting terminal of the another coil, then which leads to the delta connection. Finishing terminal, that is ending terminals of the one coil is connected to the starting terminal of the another coil, then it is called a delta, it leads to the delta connections. Okay, so next so on like that. So if we let us say R coil is there, finishing terminal is connected to the starting coil of the Y phase, and Y phase ending terminal is connected to the starting terminal of the C phase, like that. So which forms a closed path like a mesh. Hence it is also called as a mesh connection or delta connection. Okay, so this kind of connection is known as a three-phase three-wire system. Three-phase three-wire system, because there is no common point is available here, like just now what we have discussed, that is neutral point. So extra wire is not possible here. Therefore, this is called a three-phase three-wire system. Earlier one is called as a star connection is called three-phase four-wire system. So this is a simple introduction about the three-phase system. Okay, so what is the importance of three-phase system? What are the advantages? What is the balanced loads? What is unbalanced loads? What is a balanced system and unbalanced system? and what are the different connections available in the three-phase system, star connection and delta connection. Now we will see in the next class the voltage and current relationship for the star and delta connections. So line voltages and phase voltages, what is the relation? Line currents and phase currents, what is the relation for the star connection and delta connection separately. Okay, thank you for listening the class. We will see in the next class.